Okay, today we're going to be looking at auxiliary angle formula. And the auxiliary angle formula is pretty much a formula or a method that can convert an equation which looks like this, the sum of a cos function and a sine function, and make it look into any one of these four forms here. You're going to have the r value, which in this case is the magnitude or the amplitude of the function, followed by either sine or cos, as well as the x, in this case the variable, and a phase shift. And the phase shift is pretty much a horizontal translation towards either the left or the right. Okay, and this is called a phase shift. So let's have a look at a few problems, how we can convert a form of equation like this into any one of these four forms here. Okay, this is our next equation. We have to convert this equation in the form r cos, this time, of x take alpha. So let's have a go of this one here. First thing we do is work out the value of r. And again, r is equal to the square root of a squared plus b squared. So we know in this case, the value for r is simply going to be the square root, the coefficient of sine x squared, so 1 squared, plus the coefficient of cos x squared, which in this case is minus root 3. And when we do this, this is the same as the square root of 1 plus 3, which is simply just equal to 2. So we have the value of r. Now let's work out the value of alpha. To work out the value of alpha, I'm simply going to expand this side of my auxiliary equation using the cos addition identity. So we can say that we have 2 times by, in brackets, cos of x times by the cos of alpha, plus the sine of x times by the sine of alpha. And if you're unsure of how I did this, I do have another video on the addition identities. So you can have a watch of that before you watch this. So now that we have this equation here, we can actually skip a step. Okay, we know that this term here contains cos x, this term here contains sine x. So that means the coefficients of these two terms, in this case 2 cos alpha and 2 sine alpha, they must equal to the coefficients of sine x and cos x in the original function respectively. So what I mean by that is we can simply say, for this original part here, for this part that says 2 cos x cos alpha, we can say that 2 cos alpha, okay, the coefficient of cos x must equal to the coefficient of cos x here. So it must equal to minus root 3. On the other hand, we know that 2 times by sine x sine alpha, the coefficient of sine x here would be 2 sine alpha. So we know that 2 sine alpha must also equal to the coefficient of sine x out here. So that means that 2 sine alpha is equal to 1. So now what we can say is we can rearrange both these equations. We can say that cos of alpha is equal to minus root 3 on 2, and the sine of alpha is equal to a half. And when we solve this for alpha, we first need to recognize which quadrant we are in. So if I draw out a unit circle, we can say that in order for cos of an angle to be negative, but then sine of that same angle to be positive, that would only work in the second quadrant. So the angle that makes this true, we can use our exact values that we have memorized. Cos of what angle gives you a positive a half? Well, alpha would equal to pi over 6 radians. Okay, but because we're in the second quadrant, okay, this angle here would be pi on 6, that's our reference angle. The actual angle from the x-axis will be going like this. It'll be looking as 5 pi on 6. So we have just worked out that the angle that works for this solution here is alpha equals to 5 pi on 6. So now that we have both of them, we can say that our final answer is simply just 2 cos of x take 5 pi on 6. And that's how you work out the auxiliary angle in this form here. Okay, next question. We have this one here. This time we want to do it in the form r sine x plus some angle beta. So give this a go yourself first. Okay, let's work out r. R is the same as the square root of 3 squared plus negative square root 3 whole squared. In this case, that's the same as the square root of 9 plus 3, which would just be the square root of 12. And the square root of 12 can be simplified, if you were to simplify this third, as square root of 4 times 3. So that's just the same as 2 square root 3. Okay, so now that you have this 2 square root 3, let us now work out the value for x. Oh, in this case, beta, sorry. We need to work out the value of beta. So to work out the value of beta, we need to use the sign addition identity. Okay, we know that r is equal to 2 root 3. Okay, so now in brackets, we'll use the sign identity for addition. That would be sine of x cos of beta plus the cos of x times by the sine of beta. So again, we know that the coefficient of sine x, in this case 2 root 3 cos beta, must equal to the coefficient of sine x here. So in other words, we know that 2 root 3 cos beta is equal to 3. So in other words, we can say that cos of beta is simply equal to 3 over 2 square root 3. And if you want to rationalize this, times the top and bottom by square root 3. Okay, so on the top we get 3 square root 3. On the bottom we get 2 times 3, which is just 6. The 6 and the 3 cancel to just get root 3 over 2. And for the other term, we can say that the coefficient of cos x, in this case 2 root 3 sine beta, okay, so 2 root 3 sine beta, must be equal to the coefficient of cos x in the original function, which is minus root 3. So minus the square root of 3. So that means that sine of beta equals to minus square root 3 over 2 square root 3, or just equal to minus a half. So now we have this. We need to identify which quadrant is our angle beta in. Beta, in this case, will be in our fourth quadrant, because sine of this angle is negative and cos of this angle is positive, and only in the fourth quadrant is the cosine of a value positive but the sine negative. So now that we have that, we need to work out what is the reference angle. Okay, so what value of beta makes the cos of that angle equal to square root 3 over 2? Well, that would of course be pi over 6. But because on the unit circle we're on the fourth quadrant over here, with this reference angle being pi on 6, we need to say, in this case, that if we want to work out what plus b would be, the positive value for b, we need to go all the way around like this on our unit circle to give us pi on 6. Okay, and that angle there would be 11 pi on 6. So this angle all the way around is 11 pi on 6. So that would be the value of beta. Okay, beta is really equal to 11 pi on 6. So that means our final answer for this question is 2 square root 3 sine x plus 11 pi over 6. Okay, it has to be plus pi on 6 and not minus pi on 6 because they asked it to specifically be a positive value for beta. So this is our first one here. We have 4 cos x plus 3x, and we need to make it look in this form here. The first thing we can do is identify what the value of r is. To work out the value of r, we can simply use the formula that says r is equal to the square root of a squared plus b squared. And in this case, a and b are simply just the coefficients of cos x and sin x. Okay, so let's work out what r is here. To work out what r is, it's simply the same as the square root of 4 squared plus 3 squared. And that's simply equal to the square root of 16 plus 9, which is equal to 5. Okay, so we know that the value for r in this case is going to be 5 sine of x minus alpha. So now we have to work out the value for alpha. And what we can recognize is we can recognize that this is really sine of one angle, take another angle. So we can use the sign addition identity. If we use the sign addition identity, what we end up with is 5 times by the sine of x times the cos of alpha minus the cos of x times by the sine of alpha. And if I were to fully expand this through, we can say this is the same as 5 sine of x cos of alpha minus 5 cos x times the sine of alpha. So now that we have this, we have an equation that looks like this, and we want to work out what the value of alpha is. That's the only step we have left. Well, what we can do is we can recognize that this equation here has to equal this equation here, because we're trying to make both this equation and the auxiliary angle the exact same. So what we can say is we can compare the parts which contain a cos x and a sin x. So if we have a look here, I'm going to underline them in different colors. This part of my equation contains a sin x. So likewise does this part of my original function. And this part of the equation contains a cos x, like this part of the equation here. So what we can do is we can say that 5 sine x times the cos of alpha, this part here, is really going to be the same as 3 sine x. Okay, it has to be the same as 3 sine x because they both contain a sine x. Okay, so if I divide both sides or cancel out the sine x on both sides, okay, what I'm left with is that 5 times the cos of alpha is equal to 3. In other words, cos of alpha is equal to 3 over 5. Okay, so this is one equation that I have. Now let's have a look at this part of my equation. We can say that minus 5 cos x times by the sine of alpha is going to be equal to 3, apologies, it's going to be equal to 4 times the cos of x, because they both contain a cos x. But now what we can do is we can cancel out the cos x on both sides, and we can say that it's the same as this equation here, minus 5 sine alpha equals to 4. And that would simply mean that sine of alpha is equal to minus 4 over 5. So we know that cos of an angle is equal to minus, and sine of an angle is negative, and cos of an angle is positive. So if you look on our unit circle, we can see that the only quadrant in which this will be true is in the fourth quadrant. In the fourth quadrant, the cos of any angle will always be positive, but the sine of any angle will be negative. So we need to work out the angle, the reference angle in the fourth quadrant, which will give us the value for alpha that makes these two statements true. So what we can do is we can simply just work out alpha by doing the cosine inverse of 3 over 5. And what we get here is 53.13 degrees. So this is the value of alpha, which makes this statement here true. But more specifically, we know that it has to be in quadrant 4. Okay, so if it has to be in quadrant 4, we know the angle is actually minus 53.13. Okay, it has to be minus because we're in the fourth quadrant this way. Okay, so now that we have the values for both r, and alpha, we can simply work out our auxiliary angle formula. Okay, the auxiliary angle formula for this question is simply going to be 5 times by the sine of x plus 53.13 degrees. Okay, this is the last one of our generic forms. We have r cos x plus beta this time. So the last time we did sine, this time we do cos. Pause the video and give it a go. Okay, let's work out r. R is equal to the square root of 2 square root 2 whole squared plus negative 2 squared. Okay, so this is the same as the square root of 4 times 2, which is 8, plus 4 square rooted. And that, again, this is the same as square root 12, which in the last question we worked out was the same as 2 square root 3. So that's the value of r. Now let's evaluate the addition identity for cos. So 2 square root 3 times by, in brackets, cos of x, cos of beta, minus sine of x, sine of beta. Okay, so now that we have this, we can now compare coefficients. We know, okay, I'm going to skip a few steps, 2 square root 3 times by the cosine of beta. Okay, we know that has to equal to negative 2, and the reason for that is 2 square root 3 times by the cosine of beta, right? Well, that's just the coefficient of cos x. So doesn't that mean it has to equal to the coefficient of cos x here as well, which in this case is minus 2? So that's why I said minus 2 is equal to 2 root 3 cos beta. And then we can say the same for this part here. So 2 times square root 3 times by sine of beta is just the coefficient of sine x. So that means the coefficient of sine x here must also be equal to that. So if I were to write it down, that would mean that minus 2 square root 3 of sine of beta okay, is going to be equal to 2 root 3. So now when we rearrange both of these equations, we get cos of beta equals to minus 1 on root 3, and sine of beta equals to negative 1. And I made a slight mistake here. I meant to say 2 square root 2. So that would mean this is the same as square root 2 over square root 3. So when we use our calculator to solve this, we get that beta is simply going to be equal, in the first quadrant, if you work out the reference angle, is 54.74 degrees. So now that we have this quadrant, which quadrant are we in? Okay, so we know the cos of the angle is negative, and the sine of the angle is also negative in this case because you brought the minus across. So in the one quadrant in which sine and cos is both negative is the third quadrant, because in this quadrant only tangent will be positive. So now that we have this as our reference angle, what is the angle that actually gives us this value? So if we measure it from the x-axis like this all the way around, okay, what is this angle? Well, it's simply just 180 plus 54.74, okay, and that number is simply going to be, okay, if you add 180, is 234.74 degrees. So that means our final answer is going to be 2 square root 3 times by the cosine of x plus 234.74 degrees. And that's how you do this question here. Okay, this is our next question here. It's a bit of a funky one because we've changed it from x to 2x, but it's still the same principle, so give it a go. So first thing we do is work out r. R is going to be the square root of square root 3 squared plus negative 1 squared, and that's simply just going to be 2. So now we know it's in the form 2 times by cosine of 2x, cosine of alpha, minus the sine of 2x times by the sine of alpha. Okay, this is just the cos identity for cos of 2x plus alpha. So now that we have this, let us compare coefficients. We know that 2 times by the cos of alpha is really just the coefficient of cos 2x. So that means the coefficient of cos 2x must also equal to square root 3. So we can say that 2 times by the cos of alpha must equal to square root 3. And that means cos of alpha equals square root 3 over 2. Then we can compare coefficients for the next term. We can say that 2 times by negative sine 2x negative sine alpha, well, in this case, negative 2 sine alpha is really just the coefficient of sine 2x. Okay, so we can say negative 2 times by the sine of alpha is equal to negative 1. And that would just mean that sine of alpha is equal to a half. And because we're in the first quadrant, since both sine and cos are both positive, we can just evaluate either one of these for alpha. So what value for sine of alpha gives you positive a half? Well, sine of pi on 6 radians. So that is the value of alpha. So our final answer here, we have the value of r and alpha, is just going to be 2 times by the cosine of 2x plus pi on 6. Okay, and this is our last question for the day. Okay, we have r sine of 3x take alpha. So pause the video and solve this question here for the auxiliary angle. Okay, so let's work out r. R is going to be equal to the square root of 1 squared take 1 squared, or plus negative 1 squared. Okay, and that's simply just going to be root 2. Now that we have its root 2, let us now sub it into here and evaluate the sine addition identity. So here it would just be sine of 3x times by the cos of alpha minus the cos of 3x times by the sine of alpha. So here we can see that root 2 times by cos alpha, that's just the coefficient of sine 3x. The coefficient of sine 3x here is negative 1. So that would mean that root 2 cos alpha is equal to negative 1. Then we can also say that root 2 times by negative sine alpha is the coefficient of cos 3x. And the coefficient of cos 3x here is just 1. So that means that negative root 2 sine of alpha is equal to 1. So now we can say that cos of alpha is going to equal to negative 1 on root 2. and sine of alpha is going to equal to negative 1 on root 2. So the value that makes both sine and cos positive must lie in your third quadrant, because only in this quadrant is sine and cos both negative. And if sine and cos are both the same, we can say that the reference angle must be pi on 4 radians. Okay, so in this case, pi on 4 radians is the reference angle in the third quadrant. So that means you must be going in this direction here all the way around. That's the same as pi plus pi on 4, which is just 5 pi on 4. Okay, and that is the value of alpha. That would be the value of alpha. So that means our final answer is just square root 2 sine of 3x minus 5 pi on 4. And that's how you use auxiliary angle formula.